So the type of equation you will see, it will be a little different than previous questions. So they ask us solve 2 cosine of 3x minus 1 equal to 0. So instead of 1x we have 3x. So the first step we look at the equation that we have only one trigonometric function in it, and in order to solve this we're going to solve for x, but we should have cosine of 3x one side of equal sign. So we have to get rid of -1 and we need to get rid of 2. So I will add 1 to both sides. We get 2 cosine of 3x equal to 1. Then I divide by 2 both sides. I get cosine of 3x equal to 1/2. So 1/2 is something that you should know. Or in the unit circle, we have 1/2 at 60 degrees. We also have 1/2 at 300 degrees. So we have two values for x, that cosine of that is 1/2. So pi over 3 and 5 pi over 3. So let's go back to our equation. So this angle, I'm sorry about this layer, I always forget to make a new layer. So cosine of what angle is 1/2? We just saw that pi over 3 and 5 pi over 3. That means if I apply pi over 3 here, I get 1/2. Or if I apply 5 pi over 3, I get 1/2. So 3x must be equal to pi over 3, or 3x must be equal to 5 pi over 3. Not x, correct? Everything should be pi over 3, everything should be 5 pi over 3. And we are looking for x, we are not looking for 3x. I'm going to add a domain here that x should be between 2 pi and 0. That means only one revolution. For a question like this, so we are looking for x here. I cannot divide by 3 right now. We need to add 2 pi k. We need to add plus 2 pi k plus 2 pi k. Now we're going to divide everything by 3 to solve for x. So again, this is very important that you need to add this one for a question like this. Anytime there is a coefficient in x, or there is something else beside x inside of the angle, we need to add 2 pi k. So now I'm going to divide everything by 3. This divide by 3, that divide by 3. Also this divide by 3, this divide by 3. So we will get x equal to pi over 9. Pi over 3 divided by 3 is pi over 9 plus 2 pi k over 3. And the second one, x will be 5 pi over 3 over 9 plus 2 pi k over 3. So this is a set of all the solutions. There are infinite solutions here because of this k. But because we have a domain here, our x should be between 0 and 2 pi. So we're going to give value to k. When k equal to 0, if you plug 0 here and 0 there, x will be pi over 9 and x should be 5 pi over 9. And both of them are in the same domain. What about k equal to 1? When k equal to 1, we're gonna have the first one gonna be x equal to pi over 9 plus 2 pi over 3. If you find the common denominator, we will get 7 pi over 9. Correct. 7 pi over 9. And 7 pi over 9 is inside of the domain between 0 and 2 pi. We do the same thing for the second set, x equal to pi over 9 plus 2 pi over, 5 pi over 9 plus 2 pi over 3. If you find the common denominator, which is 9, 5 plus 6, if you multiply by 3, we get 11 pi over 9. So this one also works. 11 pi over 9 is less than 2 pi. So far we got 4 solutions. Now let's try for k equal to 2. K equal to 2, we have x equal to pi over 9 plus 4 pi over 3. If you add them, we get common denominator is 9, 25. If you multiply this by 3, multiply this by 3, you get 12, you get 13 pi over 9. Which is 3 times 4, 12. 13 pi over 9 also is less than 2 pi. So we also accept this as well. Let's see the second equation. Let's apply this one. K equal to 2, we have x equal to 5 pi over 9 plus 4 pi over 3. So I get 4 here because I plug 2 for the k. 2 times 2 is 4 pi. If you find the common denominator is 9, we have 5 pi plus 12 pi. We get 17 pi over 9. Also 17 pi over 9 is between 0 and 2 pi. So we got 6 solutions, and when you plug k equal to 3, then it's not going to work. K is not going to work because when you plug 3 for the k, the answer you're going to get for x is more than 2 pi. So we stop here. We got 6 solutions. 1, 2, 3, 4, 5, 6. Let's have one more example. Solve for x. X is between 2 pi and 0. This is inequality. I also can make it from 0 to 2 pi brackets. Our equation is cotangent of x times cosine square of x equal to 2 cotangent of x. Looks a little bit crazy. So we have cotangent and cosine. So for questions like this, we would like to bring everything one side. I'm going to subtract, and I'm going to move this to the other side. So I'm going to get cotangent of x times cosine square of x minus 2 cotangent of x equal to 0. We have cotangent and we have cotangent here. I will factor it. Factoring cotangent of x, I get cosine square of x minus 2 equal to 0. So factoring is one of the technique in solving this type of equation. So we have cotangent of x multiplied by this parenthesis equal to 0. That means cotangent of x should be 0, or cosine square of x minus 2 equal to 0. We have to solve both of them. Cotangent of x equal to 0. If you look at the unit circle, we get 0 at pi half. So x, when x equal to pi half, cotangent of that equal to 0. There is only one solution. The next question is cosine square of x minus 2 equals 0. So we get cosine square of x equal to 2. And make a square root. Then cosine of x equal to plus minus radical 2. So now we need to look for the x. What x makes it cosine of that is plus minus radical 2. If you look at the unit circle, all the value we have, all the value for cosine that we know are 0, excuse me, 1/2 radical 3 over 2, so the value of cosine of x is 0, 1/2. So we know all the theta for this type, for those type of angle. We don't have radical 2. So we're going to use calculator. But before you use the calculator, radical 2 approximately is 1.4, is more than 1. So there is no value for x you can find that cosine of that be radical 2. Because the range of cosine of x is between 1 and -1. So you will say no solution for this part of the equation. But the only solution will be pi half. Then if you put pi half here, and pi half there, these two left and right hand side are equal.